Hey guys!
Hey!
Here we are, folks. We're on page 214. We're talking about scatter plots and all of their happiness. So, quick recap, guys. We can have positive association, negative association, or no association, depending upon what our data shows us. Okay? Yeah, let's hop right into the
Number
fun.
one.
Here we go. How does a scatter plot show the relationship between paired data? Remember, guys, the paired data is my x and y variables, right? It can show one of three relationships. If you're not sure, just look above. We just talked about it. So it can show me a positive association. It can show me negative association. Or, of course, my favorite. It shows me no association, okay? So we can have one of those three scenarios with our scatter plot. Again, if Mr. Knoll was here, he would do more writing because he would say as your x variable increases, your y variable increases with positive. With negative association, your x variable increases, but now your y variable decreases. Okay, and with no association, we got dots everywhere. Okay? Marcy always sleeps fewer than 9 hours. Sleeps fewer than 9 hours. That means she never sleeps for 9 hours or longer. And she's never scored more than 27 points in a basketball game. Okay, sounds interesting. A scatter plot suggests that the more sleep she gets, the more she scores. The more sleep she gets, the more she scores. Okay. What scales for the x and y axis might be best used for making a scatter plot? So again, kind of tough because they don't really give us a scatter plot here. But remember, if we're going to make a scatter plot, we're going to use our maximum numbers. So in other words, she never sleeps any more than 9 hours. So if we have like a 10 by 10 grid, on our thing, like if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. There's my 10 by 10 grid, right? I would, let each x value represent 1 hour. Okay, we got to make it all the way up to, again, we're starting here at 0. She's never scored any more than 27 points. So, meaning we don't have to go any higher than that number. Or if we do, don't go much higher than that. Like if we count by 2s, are we going to make it all the way to 27? No, because I only have 10 spots here. So we count by 2, 4, 6, 8. We'd only get up to 20. Right? I think if we count by 3s here, though, I think that would be good because that would get us all the way up to 30. Okay? So again, it just depends a little bit on each one of these when we go to construct our graphs. And look, guys, I'll be honest, we're not going to have to construct our graphs all the time, but when we do, that's what we want to use, right? That strategy. Kyle says every scatter plot will have a cluster, gap, and outlier. Is Kyle right? No. Why isn't Kyle right? Why isn't he right? If you're not sure, go back and watch example 2. We just talked about it. Guys, we could have these three things, right? These are different things that we see on our scatter plots, but we don't have to have a cluster, a gap, and an outlier. We could have one of them. We could have two of them. We could have all three of them, or we could have none of them, okay? So it just depends. So no, Kyle's not right. Every scatter plot doesn't necessarily have to have a cluster, a gap, and an outlier, okay? All right, Phoebe. Here we go. She's going to make a scatter plot. With this data, what scale should she use for the x and y axis? Again, we're assuming we have a 10 by 10 graph again, right? We got 10 little tick marks. What should we count by? Well, shoe size is going to be your x, your input variable. Height is going to be your output or your y variable. Okay? So I think we can count by ones for our shoe size, if I can say it.
Shoe size.
And then the height, again, guys, Mr. Knoll and I, this is where we'll talk about the little lightning bolt that we call a break. And we could make a break in our graph. We could do all that. Or, we could just count by, I don't really care. You count by 6s, 7s. It's just bad numbers. Better to do the break thing, but we won't worry about it now. All right. Last one. Here we go. Jermaine constructs a scatter plot. There it is. We got dots everywhere. I could make a really interesting line right now. This is, again, guys, think about this scatter plot. It's visitors at a theme park. The y variable is number of visitors in thousands. So this isn't just 10 people. This is 10,000 people. This isn't 20. This is 20,000 people. Here are the months, right? We don't have a month 0, guys. Month 1 is January. Month 2, February. Month 3,
March.
Somebody said it out there. Nice job, okay?
Me.
So we only get 1 dot for each month, okay? This one says, why might clusters and outliers be present? Well, first off, do we have any clusters or outliers? Maybe, kind of. I would definitely say yes, we have an outlier
I see one.
somewhere.
I don't know if we really have any clusters.
Yeah, we could argue about clusters. Guys, where do you think you see an outlier? So where is a dot all by itself? Kind of doesn't make sense. Yeah, you got it. That's this dude down here, right? So why might we have an outlier down here? So this is month number 11. Anybody know what the 11th month is?
November.
Man, Mr. knows all over it today. Yeah, November. So if we're talking about visitors at a theme park, so they have their lowest attendance in the month of November, then followed by one of their highest attendances in the following month, which I know is December. So what would cause that, I wonder? I don't know. Should we just skip it and move on? No, of course not. Guys, think about it, right? What if this is at like a theme park? What's the most popular theme park in the United States? It's in Florida. There's a little rodent there, and he's got these cute little ears. That's right, Walt Disney World, okay?
Never been.
Mr. Knoll's never been there.
Yes, I have. One time.
Yeah, I was there one time as well.
One time today.
No, I was there a couple times. I take it back.
One
Anyway,
time.
so guys, so in December, a lot of people go. I can kind of see that, right? Maybe they go around the holidays. It's a good family gathering. Why would it be so low, though, the month before? Well, there's also this holiday we call Thanksgiving, okay? That happens to be in the 11th month of the year, which is in November, right? And let's be honest, a lot of people aren't going to, Walt Disney World, multiple times. They're just going to go once. So they're not going to go here and then go back again the following month. So we could also, I guess...
You don't eat turkey at Disney World.
Yeah, we could also deduce, guys, that, hey, there's probably some people that planned on going there in December. And so, hey, a lot of people aren't going in November because, well, we're already got a huge holiday break called Thanksgiving. And so nobody's taking any time off around that to go to Walt Disney World, okay? So, guys, there's always a story behind an outlier as to why it happened. Hopefully this one makes a little bit of sense as far as why we have one there. We'll say no, we don't have any clusters on this one. The book might argue that, hey, this is a cluster here, and this is a cluster here, and okay, yeah, maybe we could get into an argument about that, to say yes or no, but I'm more concerned with us being able to identify our outlier all the way down there in November, okay? Hope this was great, and we'll see you at the additional practice.